We're getting there. We're getting there. All right. Sorry, just had one or two things. We overran a little bit in the opening plenary, as you all saw. So I had to rush downstairs and get plugged in for this session. So, and of course, as usual, computers have minds of their own, and they decide to remember other settings rather than the ones that were set up for down here. So anyways, welcome to the Apops session. So we have two Apops sessions today. I'm chairing this one with Maz. I'm going to leave Maz to introduce all the speakers. But just a bit of background, Apops session is usually where we take the most interesting and highest scoring presentations from the program committee, the most popular ones that we feel that should be highlighted in the whole conference program. And so this is the session we have. So I would just like to ask Maz if he would please introduce the speakers. Thank you.
Thank you very much, Philip. This is Maz, but it's just a nickname. I'm Yoshinobu Matsuzaki. I'm going to co-chair this session. So the first up is Jeff Houston from Epinek. He will speak DNS privacy and update. Over to you, Jeff.
Thanks, Maz. I understand that I have 20 minutes, including Q&A, which means that we're going to have fun here. I'm going to go through some of this stuff extremely quickly, and we'll see how we go. The later stuff, I'll pause a bit. So, Maz, can I just check that you're seeing a slide now with a title on it? Yes?
Yep.
Perfect. Okay. The DNS actually betrays everything we do. And even more importantly, everything we're about to do. Because everything starts with the DNS. So as someone on the well-known XKCD noted years ago now, if Google really wants to know what's going on, having a look at what happens in the Google Public DNS Resolver would be a goldmine if they ever dared to look. Their undertaking, by the way, quite publicly is they never look. But oh my God, so much data. The DNS is just the perfect target. Everyone and everything uses it. Everything starts with the DNS. And if I could see your DNS queries, you have no secrets from me. Absolutely none. The other thing about the DNS in this world of paranoia and encryption is the DNS largely isn't. It's open, it's unencrypted, nothing secured, and tampering can't be detected. The responses are predictable because the query kind of gives what the response is going to be, and false answers can be readily inserted. It's a business. Everybody fiddles with the DNS. And interestingly, the only folk who are left in the dark are end users like you and me, because none of us really know where our queries go, and they go a lot further than you think. And quite frankly, no one knows where the answers come from. Did it come from a cache? Did it come from an authoritative server? Did it come from someone on the street? None of us know. So DNS is big business, and DNS surveillance is equally big business. And so when we talk about privacy and surveillance, we're actually talking about a few things. One, I'd like to keep things secret from other onlookers. Two, and it's slightly stretching the word privacy, I'd like to know the answers I get are the real answers, not some fake that someone's just inserted going, here you are, Jeff, use this answer, because, you know, you'll love it. I won't. So we're talking about privacy, we're talking about authenticity, and we're also talking about some form of protection around the DNS as a protocol itself. Because what we also want to do is stop people making profiles. So what I'm going to do is give you an update on the common mechanisms about trying to make the DNS a little bit tougher, a little bit more resilient. And you kind of go, but hang on a second, the DNS is public. I'm like, is the label being queried a secret? I'm like, not really, it's just a question. Is the answer a secret? Well, anyone else can ask the same question and get the same answer. So why do you think it'll be a secret? It's nothing special. There is a footnote there about steganography if someone wants to ask about it. So if the questions aren't really a secret and the answers aren't really a secret, then why do we worry? And the issue is, in some ways, it's the combination, because the IP address of the query, the original query, is me. That's my address at the moment. The query and the answer and me can all be bound together. And if you combine that, those three items of metadata, all of a sudden, plus the time, you're starting to assemble a useful bundle of information. So very quickly, the DNS is really simple. Right, wrong. The DNS is incredibly complicated. There's a whole bunch of stuff in the middle. And the issue is, it's awfully easy to be awfully bad all over the place. Corrupt the host platform, corrupt the wires, have a look at resolvers that leak and publish their logs, whatever, servers that leak and so on. And quite frankly, it's so leaky that these days, secondhand DNS queries are a business opportunity, and folk are doing a fine business on basically selling the intelligence gained from your queries and my queries. So can we make it better? Now, some of you might have seen some of this stuff before, so I'm going to go really quickly through the early bit. The first thing is, the DNS is not just a little bit chatty, it's extravagantly chatty. Hey, everybody, I'm asking a question. Everybody gets to know the full question. The root servers, the authoritative servers for the top level domains, everyone gets to know the full query name. That's really bad. That's really, really bad. Because all I need is a root server log, and all of a sudden I know far more information, far, far, far more information than I should if I was a root server operator. So maybe we should stop that. And the answer is query name minimization. And it's been around for some time now, and it's still an experimental protocol, but by and large, almost everyone uses it. These days, most recursive resolvers will only ask just enough to get the answer they're after. But oddly enough, it's not really that well done. When we try and measure it, we actually find, depending on what you're measuring, you'll either find a lot or none. Because some, indeed most of the recursive resolvers, only do query name minimization on the first three labels. And once you get to label 4, it says, stuff it, I'll just tell everyone. Which is sort of half private, whatever that means. So, 2 out of 10. Good, but, why stop at 3? Yeah. The next thing, interception and rewriting. And this is so common. If I want to go to the piratebay.org in Australia through my ISP's resolver, the answer is you can't get there from here because it's blocked. Equally, facebook.com in China is probably blocked. Lots of domains are blocked in lots of countries. And normally the way this works is interception. They just give you the wrong answer. Now, how can you tell it's the wrong answer? And the answer is DNSSEC, security for the DNS. Because a DNS response that's modified isn't genuine. And if it isn't genuine and the domain is signed, then you'll know that someone's been tampering. Because if it has been modified and the stone is signed, this says, no, that's not the answer you're after. And it will only return the answer if you're doing validation, if it can validate the answer. If someone's modifying it, it won't work. What it returns, oddly enough, is not, I smell something weird going on. It actually returns an error code called serve failed. There aren't many error codes in the DNS, and I had to reuse one of them, but serve fail is kind of not, I smell someone's mucking around with this answer, don't go there. It says, no. As a resolver, I failed. Go use another. And so the poor user doesn't stop. They just keep on trying and trying and trying until they get to a recursive resolver that doesn't do DNSSEC validation. Oops. So while about 30% of the world actually will not resolve a name that's signed but won't validate, another 10% or so will just keep on looking around to find a resolver that says, there's the answer, because it's not validating. So DNSSEC, 5 out of 10. The problem is, of course, with DNSSEC, if I'm www.potteroo.net, then potteroo.net has to be signed, .net has to be signed, the root has to be signed. For a long time ago, that was an issue. These days, more and more folk at the upper levels are doing DNSSEC signing. But even so, who gets to validate? This is again interesting. The recursive resolvers that many folk use do validation, and they won't hand the stub resolver the answer unless it's sure it's real. But how does the recursive communicate to the stub resolver, you, the answer in the open? You don't validate. I just set one bit in the answer going, trust me, this is a good answer. Oh my God, you mean anyone can change that bit? Yeah. And if you don't do your own validation, are you any the wiser? Nah. Stub resolvers really should validate. Why don't they? The answer is there's this eternal battle between speed and functionality. Validation is slow. Users don't like slow. They don't do validation. It's all faster. Insecure, but faster. Middleware and wiretapping. Well, maybe we should encrypt everything. Secure the channel. Let's go and use TLS. The web uses TLS, which DNS should use TLS. So along comes DNS over TLS or DOT. Basically what goes on is you do initial handshake. If you like the name, this is the place you're going to, and you can validate that certificate, off you go. But hang on a second, the DNS was ultra fast. It was UDP. This is no longer UDP. It's no longer TCP. It's TLS. Handshake, 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 start, 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 question, answer. So there's an enormous cost going on unless you can reuse that session. Also, the recursive resolver that could handle X million UDP queries per second can handle X hundreds of thousands or maybe only X thousand DNS over TLS session, the questions, because TLS
We seem to have lost Jeff.
Yeah, he's frozen.
Yeah. So let's see if his net comes back.
Yeah, let's wait several minutes. And if he couldn't make it, then probably we...
Yeah, so he's dropped off. So he'll be coming back on. It's the usual thing. If you have any questions, please use the Q&A button. And Jeff's talks usually cause lots of questions. So please use the Q&A so we can capture your questions there. We have limited time, so we'll probably only have time for a couple of questions when Jeff finally makes it back here. The wonders of online events. But yeah, let's see if we can come back within the next couple of minutes. Yeah, we're all poised, sitting here waiting to see if he connects back into Zoom. Yeah, I guess there must be a bit more of a significant outage that he has at his home. So
seems like he takes time to recover. So how about then let's go into the next speaker. Then if there are questions, then probably Jeff can take after all.
Yep. And we can revert to Jeff at the end if there's still time to do that.
Yep.
So I think let's move on if we can.
So sorry for that, but now we have next speaker, Susan Forney from Hurricane Electric, who will talk about RPK at Hurricane Electric. Please, over to you, Susan.
Okay, I'm going to try to share my screen here and see if it cooperates. There we go. That's looking good. I'm looking forward to hearing the end of Jeff's talk, so hopefully he will be able to reconnect. So I'm Susan Forney, and I'm here to talk to you about RBKI at Hurricane Electric. And let's see, this will click forward for me here. February 24th actually marked 1 year since Hurricane Electric began deploying RPKI route validation. And in the year that has passed, the global community has made significant progress in the adoption of RPKI ROV. Hurricane Electric's, what I'd like to talk to you today is about Hurricane Electric's deployment and exactly what went on globally. And then the tools that Hurricane Electric has that can support you in the event of a problem, and a look at RPKI ROAs and how adoption is faring, because after all, it doesn't do you very much good to be filtering for RPKI invalids if there aren't any prefixes with ROAs. So let's go and look at what happened last year. 2020 was a really good year for routing security. 8 large ISPs began validating origins with RPKI. And I should mention that they're not on this list, but PCCW and AT&T and Tata were all validating their peers for RPKI and filtering for invalids before the beginning of 2020. And then Telia kicked off 2020 by dropping RPK invalids, and that's the same month that we implemented phase 1 of our RPK project. And in March, we were joined by NTT. In May, we had GTT, Lynx, TerraHost, and WorldStream. In June, Cogent and Vocus joined, and that's when Hurricane Electric also finally achieved 0 RPK invalids. In July, we had Telstra, Quadranet, Videotron, GRIX. And in August, there was Google and HKX. And then last in September, there was Swisscom and also Netflix. So that was a lot of progress in 1 year. Now, as was noted with in many network operator groups discussions, our system does not rely on routers with a full set of validated ROA payloads or VRPs from an RPKI to router protocol. Instead, our first line of defense is the filters we generate daily for our peers that validate the RPKI ROAs and IR records. Like many ISPs, we have devices deployed at our edge that do not support the RTR protocol. So we had to design a system that and deploy our own system because of that. The system we deployed will identify an invalid announcement and remove it from our table in less than a minute. We were able to do this without replacing our existing routing infrastructure, which means that filtering for invalids does not have to depend on what your equipment vendor does or does not offer. Now, the first tool I want to talk about is, or the first thing I want to talk about is the filters, which we can see in our tool, routing.he.net. All our filters for our customers are refreshed daily. And if you're curious about the algorithm we use to create these filters, you can see it here if you click on algorithm, which I have helpfully circled in red because I'm not very good at PowerPoint automation. And if you did that, you would get the detailed explanation of what we're doing. And in the interest of time, I'm going to just give you a quick rundown about how the filter works, the 5 high-level steps. The first one is that we look at the ASN and attempt to find an AS set to use for the network. And after that, we collect all the routes we're receiving from all the BGP sessions for this AS. And then for each one of those prefixes, we perform rejection tests. The prefixes that survive the rejection tests every prefix goes through an acceptance test. And then prefixes that are not explicitly accepted will be rejected. Now, if you want to know, I guess you're probably wondering how all this stuff affects you and what are they doing? We have a couple of tools that can help you out here. First, there's bgp.he.net, which is our classic site featuring information about public sources about BGP and the internet. And then we have routing.he.net, which helps you look at any network that advertises prefixes to Hurricane Electric and sees how we filter the routes. So let's start with bgp.he.net, where we were retro before retro was cool. This is the page that you are going to get if you put your AS in the little box up there and click search, and then you click the prefixes v4 tab, and then you would see this page for whatever AS you were looking at. I'm looking at AS 44684 Mythic Beasts because they're related to me and they can't get mad at me if I use them as an example. And what we see here for each prefix is that there's a little green check mark by each one of them. And what that means is that every one of these prefixes has a IRR route object. So that's good. And then we see all but one of these objects has a green key by it. What that means is each one of these prefixes has a valid ROA. So that's good. Notice that the one that doesn't have a check mark by it is an unknown. It doesn't have a ROA at all. Now, like on this page, if you saw a red key by a prefix, that would mean that the prefix has an RPKI invalid. Similarly, if you saw a red check mark on the page, that would mean that it had an invalid route object. So that's how you tell, what's going on in bgp.he.net. Now, you probably know what your prefixes are doing and how your IR records are, but this is a great way to take a quick look at what's going on with your peers or your downstreams if you want to know what they're doing and what you should be filtering. So in addition to filtering into documenting the filtering for our algorithm, routing.he.net is where you can find the reasoning behind what prefixes were accepted from your network. If you have BGP sessions with Hurricane Electric, you can just enter your AS into that little blue box and hit submit. And when you do, you'll get a page that looks like this. It has 4 tables on it. The first one is the main table that gives general information about the network that we get from IR sources in places like PeeringDB. The second table is the filters table, which shows which filters are going to be applied to these sessions. And you'll notice that the AS set is noted in the second column there, in this case, AS Mythic for these guys, both AS for IPv4 and v6. The third table is all of the prefix lists that will be applied to each router where a session is hosted. And the fourth table details all of the sessions. So if we want to find out what policy is going to be used for this for these IPv4 routes or IPv4 prefixes for this AS, all we have to do is click under the policy column in the second table is click display. And when we do that, we're going to get a screen that looks like this. And that's going to be the actual prefix list that is applied to those BGP sessions. Now, if we're wondering why we ended up with that, we can go back to the page and we can go on the same filters table under reasons this time and click display, which again, I have handily highlighted in red so that you can see what I'm doing. And we will get this. And what this is a list of every single prefix that we saw and why we accepted it or rejected it. And in this case, the prefixes were all accepted. And you can see that it's noted whether they are RPKI status invalid or not and why we accepted the prefix. So now that we've been doing it for a year, I can share the things that we've learned. And the first thing we learned was that Frank Sinatra is right. You really need to do this your way. The best way for you to roll out RPKI may not be the way that everyone does it. And getting RPKI ROV right actually does not help you a lot if you don't have IRR filters that are right, because you're still need to use them for for AS path validation, and you'll need them for validation for any prefix that doesn't have ROAs. And tools can give you a big advantage. Routing.he.net and bgp.he.net were out there a long time before we deployed RPKI ROV. But when we did, they were there to explain what we were doing. Transparency will help you a lot when you're doing a rollout. A lot of operators have not paid attention to RPK or IRR records. And for those people especially, it helped to have tools out there that could provide them with some answers. So now let's take a look at how many networks are creating ROAs for the prefixes. And if we look at the global table for IPv4, we can see that I took these snapshots actually last week, actually not even really, it's 5 days ago. And what we can see is that we've got 28% of the prefixes in IPv4 have RPKI ROAs, and less than 1% of those are invalid. For IPv6, we've got actually doing a little bit better. We've got 32% of the prefixes having ROAs, and less than 1% has invalids. Fun fact, the amount of invalid ROAs actually declined year over year. It was about 7,000 in March of 2020, and now it's down to about 4,500, which is saying something because the IPv4 prefix pool has increased by over 5% over the year. So it's not only keeping up, it's gaining. So how do we look for the year? Well, in March of 2020, we had about 19.5 of the IPv4 prefixes with ROAs. And you can tell that having operators at home with out any place to go gave them some time to clean up their routing security, because we got up to 23.86% by September. And then of course by this month, we're up to 27.6%. So that's pretty good progress. Now, what we're going to look at here really quick is the total IPv4 space by RIR, because to see where we're going, we have to break this down by RIR and look at where we need to focus on for creating more ROAs and getting more RPKI deployed. And so quickly here, what the fun thing to notice is that Aaron has 37% of the total IPv4 space. And there's a lot of reasons for that, and it would probably take a long time to explain. Just trust me, that's how it is. So now if we take, in this next slide, what I have taken the number of ROAs, or the percentage of ROAs by RIR, and broken this down, and I put it right next to those green columns you saw from the last slide, which is the percentage of IP space that each RIR commands in the global table. And Epinek actually is doing pretty well. You think, oh, they only have 9.2% of their prefixes in ROAs, but that is double where they were last year. So they have made a lot of progress and they're doing great. Epinek is at almost 30%. Aaron is at 14%. Lacnik is almost 35%, and Ripe is hitting it out of the park with 43.3%. Now, what's important at this table is that Aaron has 37% of the IP space, but only 14% of that 37% has ROAs. If we are ever going to get to the point where ROAs are the primary way to authenticate an origin, a lot of work is going to have to get done there. Now, if we look at the same exact thing for IPv6, it actually is a prettier story. The first thing is that IPv6 doesn't suffer from the same problem as IPv4 with a lopsided distribution of prefixes. For IPv6, the RIRs can get as many prefixes as they need, so it's not a problem. But we also can see that there's still a region that's lagging a little bit far behind. Epinek is doing even better in IPv6 than it is in IPv4 of 21%. Epinek, 30%, very respectable. Lacnik, 29%. 46.35% for Ripe, those overachievers. And there we are with Aaron, still 19% better than IPv4, but it has to do better in order to get, it has to do better than that in order to get more ROAs in IPv6. The reason why Ripe is so far ahead of everybody, if you don't know and you haven't been exposed to it, is they have gone on a very aggressive and ambitious campaign to evangelize ROA creations, and you can see it is working out for them. So this brings us to IRR records, which unfortunately are still the last defense in routing security. And while we have been making great progress in ROA creation, we still need IRR records because they're the only way to validate AS path and prefix announcements. So if you are already not doing this, not already doing this, you should be maintaining your IR records as accurately as you possibly can, because they're still the only way to evaluate ASPath, and you are going to have to evaluate origins for everybody who doesn't have a ROA. Filter to deny both a good idea. Use ASPath filters or peer lock to keep people from advertising their upstream routes to you, which you don't want. Actually, they don't really want that either, but some people do it anyway. Announce all of your IP space, because it is easier to protect it if it's already in the table with a valid origin and ASPath. And of course, create ROAs for those prefixes. And then set prefix limits for all of your peers. So here's what happens when you don't do those things. The first one I'm going to look at is the November 2018 Google route leak, which affected Google and a number of others for about 74 minutes, when a small unfiltered ISP advertised about 500 of Google's prefixes that it had learned from a route server. Now, of the things in our toolbox, what could have prevented this? RPKI ROAs? Well, not really, because those were Google prefixes and they had valid origins. That wasn't a problem. Path filters wouldn't have helped because this was not a leak from upstreams. IRR path filters, you bet, that would have helped because this particular ISP was not authorized to advertise these prefixes. And prefix limits is a maybe. It would have helped as long as the prefix limit was lower than the extra 500 prefix this guy advertised, assuming there weren't any others. So let's look at another problem, and another reason, and that would be June 24th of 2019 outage that happened in Verizon. And this was a route leak that happened when a small company used a route optimizer, which ended up making this little downstream the preferred path for a large quantity of internet routes that happened to be transiting Verizon. Would RPKI ROAs have helped? Not much. I mean, invalid paths might have happened because some prefixes would have been wrong, but it wouldn't have gotten most of it. ASPath filters, peer lock, yes, definitely, because this was advertising upstream, so that would have helped. And IRR path filters, you probably would have needed that too, because this wasn't authorized to obviously be advertising these networks, and maximum prefix limits would have shut this down right away. So please, if you're not doing it already, please secure your stuff. Now, finally, what could make routing even more secure? Well, ROAs out there take care of route validation, but we still need a better way to validate the ASPath. Today, networks document the ASNs they're authorized to advertise to other networks, and you just have to trust them. A more secure system would have the clients identify their providers. And I've given you a little graph here to illustrate how that might work. Unfortunately, we don't have a way to do that yet. But until we do, thanks to a great year for RPKI, routing is a lot more secure. And that's all I have for you today. Thank you for your kind attention. Do you have any questions?
Thank you very much. Do you have any questions? If you have, please type in the Q&A box on the Zoom. Can I ask one question? So
Okay.
Susan, how do you think, how long does it take to deploy path validation?
Path validation?
Yeah.
Well, I mean, how we did at Hurricane Electric, we've been actually filtering all of our peers for ASPath for very, and for IRR through IRR records for a very long time. But I think it's like, I don't know, I want to say like over 5 years. And what we do is we go through every single peer and we generate a new filter every single night. And that's how we do it. And we do it through automation. And it honestly isn't that complicated. You can do it with BGPQ3. Anybody can do it. And it's easy to automate. So, if you're intimidated, it really is not. It's one of the easier things you can do. It's not that hard.
Okay, we have one question. Would you please explain peer locking a bit more?
Oh, peer locking a bit more?
Yep.
Okay, peer locking is where ASPath filters have been out there forever. But what peer locking does is you set up a ASPath filter that filters out paths that have well-known upstreams in them. like AS701 Verizon, or AS5536, Lumen, or all the big boys, AS6939, of course, Hurricane. You don't want that in there either. Any of those, any large ISPs, or even your own upstream providers, you might put those in there. Anybody that that you wouldn't want to, that you wouldn't expect that peer would be advertising routes on behalf of. And that protects you from them leaking their upstreams, which happens a lot more often than you might think. I mean, honestly, I catch people doing that several times a week. And I don't see everything several times a week.
Thank you very much. Thank you so much. So before going to the next speaker, as we have Jeff online. So Jeff, can you resume your talk?
Thanks, Maz. Unfortunately, the power to my entire house went out. And with it, of course, the internet. And I certainly spent some time trying to figure out battery power, but the power came on eventually. So I'll resume, but I'm going to jump forward a little bit because, I can. And I actually want to start with DNS and privacy and look at the latest developments in this area. You see, the problem is it's the combination of who you are and the query you make that really makes life incredibly interesting for onlookers. So is it possible to separate who you are and what you're asking for? And one of the most amazing approaches was actually in a DNS OARC workshop from a few years ago called Oblivious Dns. And it's a clever use of encryption, but not in the channel. The encryption actually happens in the query name itself. So I take the query name and I encrypt it with my own key. So far, so good. I use a session key. And then I take the public key of a server out there that is cooperating with me. And I encrypt this entire thing, the public session key that I'm using, together with the name I'm going to, and add a suffix of this resolver out there that, if you will, is playing with me. I send that into the DNS. It's just a strange query. The query name is just a bunch of letters. The recursive resolver handles this quite normally without knowing what the query is. And by the time the query gets to the authoritative server that you're looking for, my identity has disappeared. All the authoritative server sees is this recursive resolver. Because it has the private key of encryption, it can decrypt both the query and the session key. It becomes a recursive resolver, does the query on my behalf without knowing who I am, and then encrypts the answer in the session key and sends it back through the DNS. Brilliant. But it's still port 53. Yeah. But I can still use DOT and all the rest of that stuff to actually get to this resolver. The problem is you've got to encrypt it inside the query name, and that's some limitations. More recently, some folk, including Cloudflare, came up with a similar approach that actually takes DNS over HTTPS and double encrypts it. So you need two cooperating agents. You send the double encrypted query to the proxy that unwraps the first layer and then sends the encrypted inner layer off to the target, the recursive resolver that then handles the query. Now, as long as that proxy and that target never ever talk to each other, the target doesn't know your identity, the proxy doesn't know the query, the name server knows nothing. And so you can do a decent job as long as two parties who you've never ever seen don't ever talk to each other under any circumstances. Which is a lot of trust, isn't it? Nice idea, but a lot of trust. So if collusion happens, it all breaks apart. What if I go further? Because if you think about it, I can pass any old stuff through the DNS. The DNS is merely just a lookup algorithm. So what if I hash the entire zone as the publisher and publish the encrypted zone as the zone? People who share this key can encrypt their queries ask in the encrypted zone. It's a bit like NSEC3 is applied to the entire zone, and get back answers. Now, of course, the problem is that shared secrets amongst all the folk, the zone publisher and the clients, is an oxymoron. There is no such thing. So nice idea, but. So what are we going to do about this? How are we going to resolve it? Because if I use an encrypted session to a very busy open resolver like Google or OpenDNS or Cloudflare or so on, no third party can see it, but that open resolver is privy to all my secrets. Now, it's making all the questions to the authoritative servers, that's true, but nevertheless, I am sharing my secrets with one of these open resolver folk, like it or not. And that's a large amount of trust. And I don't pay them anything. So it's free trust, which you really, really shouldn't trust. So maybe I should not really trust all of them at once. And instead of having a single open resolver that sees my complete DNS profile, maybe I should just round robin, query to Google, query to Cloudflare, query to OpenDNS, query to Quad9, and around and around and around. No single open resolver is going to get a full profile. Now, at the moment, we're off in noodle land doing brave experiments on the DNS. Will this ever become mainstream? Will this ever become lights out for the DNS, it's all over? I doubt it. It's interesting work, but I don't think it's going to be mainstream. Part of the issue is the DNS is the last of the free internet. You don't pay to have your queries resolved. That's not the deal. So anyone who sets up an open resolver, particularly if it's popular, is doing this as an act of unrequited love, because the money isn't coming from the people who use it. And you can't change the answers because that's not part of the game. So you can't really get money from advertising. You can't really get money from users. You can't get money. And so any really popular open resolver becomes a success disaster. The more they're often they're used, the greater the funding problem, the greater the funding problem, the greater the problem. And so literally the pressure to monetize that DNS log is almost inevitable unless you're so big it doesn't matter. And so normally the default operation of the DNS is the ISP funds it because that's who you pay for your service. And they operate a recursive DNS because I fund them. And so these large open resolvers are living on the knife edge of viability. And they're doing it because, well, I don't know why they're doing it actually. So the default's going to be the ISP. And as far as I can see, ISP-based provisioning is going to continue. And it's probably going to stay there without channel encryption, because the folk that's in the best position to listen on the wire between you and the recursive at the ISP is the ISP. There's no benefit in listening on the wire. They run the recursive. The other thing is most users never, ever, ever play with the buttons, even if they knew there was a button. I'm like, how do I change the DNS resolvers on my iPhone? Is there an app for that? And so in some ways, the default settings are going to be as they always were, provisioned by the service provider. Some applications are going to shift to DOS support. But on the whole, after the mess that Mozilla made of this with Firefox, they're going to use the default ISP-based resolvers, because shifting an application's DNS to somewhere foreign is kind of a bad thing to do, and the application itself loses favor with its users. So while some applications will do that, my suspicion is that DOH will become the preserve of malware, because you can never see it. So if the browser folk manage to convince us to use channel encryption everywhere, and HTTPS has worked, why not DNS? Well, the answer is, quite frankly, there's no motivation. There's no financial return in DNS resolution. There's no commercial impetus. A lot of the environments we live in, governments, etc., use DNS oversight and alteration as a mean of content moderation. And so folk who are using DNS lists and DNS blocking would have nowhere to turn if the lights turned off. So there's little appetite to make that harder. And browser vendors, well, the browser might go sideways, but if it goes too far, they're going to get pushback. And so right now you get things like Chrome, which is going to encrypt to the ISP's resolver, but that's it. It's not going to jump over those leaps. So you're still using the same resolver you were ever going to work. But that gives you a very interesting compromise going on, because browsers and applications are now getting impatient with platforms. All those software libraries in iOS, all those software libraries in Android change slowly, way more slowly than most application folk want. And the whole reason why we're pushing a whole bunch of functionality, transport layer protocols and the DNS, up away from the platform libraries and into the application, is to give the application way more control over its fate and its destiny. And so you're going to find that platforms are going to have one version of the DNS. My laptop, my phone is going to look somewhere, but my browser might look elsewhere, which is going to lead to some really interesting failure cases when it all goes horribly wrong. So what does this mean? Well, if you are going to play with the buttons, and I don't think you should, the careful choice of an open recursive resolver and using encryption will go a long way down this path. But quite frankly, encrypting to Google is sharing all your secrets with Google. Encrypting Cloudflare is sharing all your secrets with Cloudflare. There's an awful lot of trust going on to just different people, whom in this case, you're not paying, whereas you are paying your service provider. So in some ways, there's a world of compromises out there. And even if you do nothing, that might be the best course of action. It's up to you. Thank you.
Thank you, Jeff. Is there any question from her? Anyway, thank you, Jeff, for your talk. Now we are going to the last, but not least, Mohammed Adbur Awal from NSRC. He will speak on Rpki invalids and going away. Awal, are you there?
Yeah, thanks, Masan. Good morning, Apricot. Good afternoon or good evening, because it covers the whole range of time zones. My name is Awal, and today I'm going to talk about my presentation on Rpki. And I think you guys can see my slides now. So a little bit of background of this talk is I've been a Mozilla fellow for more than about a year, and I have worked on Rpki deployment and enhancing routing security in the Southern Asian region, specifically 9 countries. And based on that project works, I have done some research and I have some stats to share with you about Rpki invalids. So here, these statistics has been taken from the Manners Observatory. It shows that the number of routing incidents that happened for all the 9 countries that I have worked with over the period of about 1.5 years. And you see that almost every month for every country, there are some routing incidents happening, and it's actually not gonna go away. And these incidents includes different kind of routing misconfigurations, route leaks, prefix hijacks, and so on. So one of the common routing incident is the prefix hijack, and that's how the Rpki comes into the picture. And you see that over the period of more than a year, there have been massive effort in these 9 countries, and I have worked with many of the network operators to create Rpki ROAs for their internet resources, as well as help some of the network operators to deploy Rpki origin validation. The graph shows that all the 9 countries collectively done massive work, and they have improved their Rpki deployment, and they have created ROAs for their prefixes, and hence the number of unknown prefixes reduced, and the number of valid prefixes in the BGP table increased. But if you see the bottom of that diagram of the stats, you see the there is the RPKI invalid routes always exist in these countries. And I'm quite sure that it is similar to any region in the world, that you have some percentage of invalid routes still exist, even though you probably have done a lot of efforts to minimize those, but it's still there. So about 1% in these 9 countries, the 1% prefixes are still invalid, and that is actually about 600 prefixes, 590 prefixes, and I have checked it until January. So one of the common reason of that is the prefix hijack. So there is a example of a prefix hijack. You see, as 65500, it is announcing its resources. In this case, the example shows that 192.168.00/24 is announced from AS65500, and it is traversing to the internet. And at some other part of the world, AS64805 is receiving the prefixes, and that's why the traffic returns to that network. But if someone else pretend that these resources are owned by someone else, for example, 65510 is announcing the same prefix, and they are not legitimate prefixes. That's why this is a prefix hijack. And if there is no other mechanism in place, then that traffic would probably go towards a hijack network, right? So this is a very common scenario, happens many times. And how we can get rid of this? So RPKI has a role to stop this kind of routing incidents. So what is RPKI? When we talk about RPKI, we're actually talking about 2 things. One is the route origin authorization, which is a digital object, and it is signed by the resource holders. So for example, if you are a member of Epinek and you have internet resources delegated by Epinek, so you can sign your resources with your digital signature, and then this signature, this digital object is called a route origin authorization, or ROA. And the second part is the route origin validation. So if you want to validate the BGP prefixes that you are receiving from your peers or from your upstream providers, so what you can do is you can collect all the ROAs from different servers, and then you keep it in your RPKI validator, which is a relying party software. And that relying party software has all the VRPs. When your BGP router receive a prefix from your neighbor, and it talks to the validator and checks the status of the prefix based on the ROAs that it collected from the validator. And based on that, you can actually create rules whether you want to accept it or want to drop it. So what makes a route RPKI invalid? So here is an example. So when a resource holder creates ROA, it actually consists of 3 things. One is the prefix itself, and the other one is the AS number. And you also need the max length. That means with that ROA, what is the prefix size that you want to cover within this ROA? So you see the ROA that has been created with these 3 combination, and on the right side, you see that this ROA covered some prefixes, and some prefixes are not covered because of the max length. So here we have a prefix of /22 and the max length is /23. That's why the /24s are not covered by this ROA. That's why they are invalid. And here's an example. If you have the ROA in your repository, and then when your router receive a prefix, and based on the prefix and the AS path, AS number that originated that prefix, that could be a valid prefix, invalid prefix, or an unknown prefix. So when all the parameters like the prefix, max length, and the S number is a match with the ROA, then it is a valid. And if it is not found, that means the ROA is not created, then it's just not found. The invalids could be of three types. One could be the max length invalid. That means the prefix is okay, the S number is okay, but the subnet size is not covered by a ROA. And there could be origin invalid, which is the prefix size is totally okay, but the S number that originated the prefix is not legitimate to originate it. So that's why it's an origin invalid. And the both of these two invalid combinations could also be possible. So it is like max length plus origin invalid. So here is an example. If you check some certain prefix, you would see it's a valid or invalid or a max length invalid, origin invalid, or both. So there are some status you will find once you check a prefix. Here is some example taken from Hurricane Electric's BGP portal at some point, and you see that some prefixes are originate from a S number that is not legitimate to announce it, or there is no ROA of that prefix and S combination. So that's why it's an origin invalid, and that S number shouldn't announce that prefix. This is max length invalid. The S number is totally okay, prefix is okay. The resource holder somehow mistakenly configured the routing, the BGP announcements that doesn't cover by their ROAs. So this is clear that there is a /22. There is a ROA of a prefix /22, and the BGP announcement is of /24s, and they are marked as invalid. More examples here you see because of the misconfiguration of the ROA and the BGP announcement, and that's why a lot of prefixes are invalid even though they are done by the legitimate resource holder. This is updated end of the January and taken from Anurag Bhatia's RPK portal. Thanks to him for providing the data to me. And here is the status for all the 9 countries, all the 590 invalid routes, and most of them are from India, Pakistan, and Bangladesh. And you see on the right side that the type of invalids are mostly by the max length invalid. So the resource holder should be careful when they create the ROA and do the BGP announcement. So this can be done if they check their ROAs and their BGP announcements. About 47% are origin invalid, which is like this prefix shouldn't be announced by a S number because the S number is probably not a legitimate owner of the prefix. About 3% have like max length plus origin invalid. And this is again from Anurag Bhatia's portal. I put it here just to show you that the South Asian operators, they have the invalid prefixes, not so consistently dropping. It has dropped sometimes and again introduced by some other operators. So it's not going away. So why invalid exists? One is, of course, because of incorrect ROAs. Probably the resource holder is creating ROA and the BGP announcement is done by somebody else. So there are wrong BGP announcements as well, probably because the network engineer who is configuring the BGP and the resource holders Epinek portal is managed by somebody else. So there is probably lack of synchronization between these two activities. But most importantly, we should drop invalids, and then we might not be able to see those invalids in the BGP table. And what we should do is we should create our ROA correctly. We should filter our prefixes and make sure that only legitimate prefixes are originated by our S number. And we should also ensure that either by our network operator, our network, or by my upstreams are doing RPK invalids and dropping the invalid prefixes. And if it is done by both the IX operators and by the transit providers, probably this should be okay, and invalids should go away. And the left side shows that the routing infrastructure is a demo routing infrastructure where both valid and invalid route exist. But if the route RPKI origin validation are in place, probably the invalids will be going away. And it is not quite easy, but we are hoping so that in very near future, we'll see that. Thank you. Thanks, everyone. Over to you, Masan.
Thank you very much, Awal. Do we have any questions? If not, thank you, Awal, for your talk. And now over to Philip.
Yep. So thank you very much for that. Thanks to all three speakers, and even with the disturbance of Jeff's house losing power entirely, we overran a little bit, but just to cater for us starting slightly late and then dealing with the power outages as well. So I realized that we only allowed 20 minutes, including Q&A for each session, which makes it a bit quick for everybody, but we hope that with the speakers and the participants, you understand that we don't want the sessions to be extremely long. So thank you for making your presentations fit into the time that we had available. Just notice there's one question from Aftab. Did you manage to check if they have covering routes for the invalid max length? That's for you, Awal.
Yeah, I have checked that. And actually, they don't have those. They have the ROA. And actually, those stats are taken from the BGP table. So they have the invalid prefix announcements because of the max length.
And then somebody's asking about Aaron if I have Aaron subnet, do I need to transfer to Epinek if it needed to be advertised from APAC, Asia Pacific? And the answer is no. The routes don't know, or the prefixes don't know, or don't care which registry they were delegated from. They just care about which autonomous system they originated from. So. And that, and then there was so I'm just trying to catch up. DNS issues arise. I'm not sure how DNS is related to prefixes being announced, but maybe this is something we can talk about offline. Anyways, I think we'll call it a day for that. As I say, we're well over time. As you leave the Zoom session, the poll will pop up, and please, if you will answer that one, if you can, just to let us know about the session. It's just the standard Zoom poll. We have the social event starting in 7 minutes, maybe with a bit of slippage, but it'll be starting about 7 minutes or so. So. That social event is hosted by PHNOG, so please join that for what they promise will be an interesting couple of hours or so. So the information about the social event is on the website, and it's also been posted in the chat as well, if you want to click the link there. Otherwise, please rejoin us tomorrow. We will start at 11 a.m. Philippine time. So +8 UTC, or whatever time zone it is in your part of the world. Hope you enjoyed today. Please enjoy the social this evening if you join it. Otherwise, we'll talk to you and see you all again tomorrow. Thanks very much.